Welcome to Chalk and Talk, a podcast about education and math. I'm Anna Stokke, a math professor and your host. Hi, everyone. If you've tuned in before, you know I usually bring in amazing guests to share insights, research, and practical tips for learning math. But today I'm going to switch it up a little because I want to take some time to summarize something that's come up a lot in our discussions, mastering math facts. So today it's just going to be me. This episode is inspired by the overwhelming response to conversations with Dr. Brian Ponce, a psychologist and math facts researcher. After those episodes, Brian and I received a flood of messages from educators worldwide sharing their concerns about students struggling to recall basic math facts and looking for effective methods to help. So I thought it would be helpful to create a practical episode summarizing the best ways to build math fact automaticity based on my conversations with Brian and other researchers. My hope is that this episode will be a valuable resource for anyone working with students, whether you're a teacher, parent, tutor, or an older student who wants to strengthen math fact fluency. This episode is for you. I'll be walking through some empirically validated techniques adopted by the MIND program, which is a free resource Brian co-developed. These techniques have been shown to work with a wide range of students across age, skills, and settings. A huge thank you to Brian Ponce for providing the framework for today's discussion and for guiding me through the supporting research. I'd also like to thank Amanda Vanderheyden for her valuable feedback and suggestions for this episode. On the resource page, you'll find articles authored by both of them, along with work by other researchers I've had on the podcast previously, like Robin Cotting, Ben Solomon, Matt Burns, and Paul Kirshner. Many researchers across fields and research groups have data that converge on high-quality math interventions supporting the instructional hierarchy model, which forms the backbone for today's episode. Automaticity with math facts is a foundational skill that is critical for success in math, and I'm trying to do my part to tackle what Brian calls a math fact crisis. So, on that note, if you know anyone who might benefit from this episode, please do me a favor and share it with them. Now, without further ado, let's get started. So what is automaticity and why is it important? Automaticity with math facts means being able to recall facts instantly without having to stop and think about it. If I ask you, what's 6 times 7? And you immediately say 42, that's automaticity. You're not pausing to count on your fingers or trying to come up with a strategy to figure it out. As a mathematician who has learned a lot of math and applied a lot of math, I know that math is relentlessly hierarchical. It's like climbing a ladder. Every rung is dependent on the previous one. Mastering math facts is like the bottom rung. Everything after that depends on that rung being strong and reliable. Once math facts are memorized, everything else becomes so much easier. It reduces cognitive load, which frees up space for your brain to concentrate on more complex problems in, say, algebra or geometry. When students don't have math facts memorized, they get hung up on things like factoring polynomials or solving algebraic equations. Once math facts become automatic, it's also easier to learn and gain fluency with mental math strategies, so you can do mental calculations with larger numbers. You may notice that I use the terms math fact automaticity and math fact fluency interchangeably throughout the episode. While these terms originate from different fields, they essentially mean the same thing: responding quickly and accurately. Can anyone memorize math facts? Well, if a child can memorize things like song lyrics, dinosaur names, or their route home from school, they should also be capable of memorizing math facts. Having said that, it may take some people longer, but it's important to invest that time. With enough practice opportunities and the right approach, they can succeed. This is an investment in a child's mathematical future. They'll likely use math facts almost every day for the rest of their lives, not just in the classroom, but in real life situations like calculating discounts, managing finances, or figuring out a tip at a restaurant. So, this is important. Math fact fluency is the foundation on which future success in math is built. Now, let's get into the practical side of things. How do we help students build automaticity? I'm going to walk you through some research backed methods. But first, an important thing to keep in mind is that the method should meet students where they're at. This aligns with the instructional hierarchy I mentioned earlier, which tells us that students move through different stages as they learn. I'll include a graphic on the resource page if you're interested to learn more about it. Now, there are two stages of the instructional hierarchy to consider when building automaticity with math facts. The first is the acquisition stage, which is when students are often inaccurate, so they're still building accuracy. Think about someone learning to skate who keeps falling down all the time. They're still building accuracy with that skill. It's the same with math facts. A student in the acquisition stage with math facts still has difficulty getting the fact right. They know that 4 times 3 is 4 plus 4 plus 4, but they still struggle to come up with 12 as the correct answer. The second stage is the fluency stage. The fluency stage happens after students can answer math fact questions mostly accurately, but are still slow. Back to the skating analogy, someone in this stage can likely stay up on their skates, but they're wobbly and slow. They're getting there, but they won't be scoring any goals in a hockey game. With math facts, a student in the fluency stage can figure out the math fact, but it's not automatic. There's some thinking going on that slows them down before they can tell you that 4 times 3 is 12. When students are still working on building accuracy, it's important to scaffold by practicing a small set of new math facts at a time until they can recall them accurately, rather than overwhelming them with too many facts all at once. When we're building fluency, we need ways to make sure they become faster so that the skill becomes automatic. Fluency building applies to all behaviors, not just math facts. Just as golfers perfect their swing or musicians master a musical piece, fluency development enhances performance across many areas. Also, keep in mind that frequent short sessions are likely most effective, and practicing math facts daily is more effective than practicing every other day or once a week. So, how frequently should students practice math facts? A good goal is 4 minutes daily, ideally twice a day. I'll add a link on the resource page to a recent study showing that daily practice is essential for achieving the highest success rates. What facts are we talking about? Well, basic facts should include addition facts with all single-digit positive integers between 1 and 9, so up to 9 plus 9, and the related subtraction facts. Multiplication facts should go up to 9 times 9, or, if you're ambitious, up to 12 times 12, and the related division facts. In terms of fluency, it's good to aim for 40 to 60 math facts correct within 1 minute. When should students have math facts mastered? Ideally, aim for automaticity with addition and subtraction by the end of grade 2, and with multiplication and division by the end of grade 3. The goal is to get these in place early to help with new learning of more complex problems. Having said that, it's never too late, and it's always important. Work with students at any age to build automaticity using the techniques that I will outline shortly. I'll also include a few links on the resource page that list grade level milestones. Today, I am focusing specifically on committing math facts to memory. By this stage, students have already worked with things like number lines, arrays, and manipulatives. They understand that multiplication is repeated addition. Now the goal is to help them solidify the facts in memory so that they can recall them automatically. To commit facts to memory, it's crucial to quickly pair the stimulus with the response. For example, pairing 7 times 8 with 56. This isn't the time to use manipulatives, draw arrays, or break the problem down using decomposition strategies. The goal is to minimize the time between seeing the fact, 7 times 8, and recalling the response, 56. It's all about forming a direct connection between the stimulus and the response. Think of it like training muscle memory in sports, like shooting a hockey puck or swinging a bat. You don't want to focus on each part of the movement. To perform well in a game, it needs to be automatic. The process for becoming automatic with math facts is like those repetitive practice shots at the net. It's like building muscle memory so that recalling the fact 7 times 8 equals 56 becomes an instant reaction without having to break it down. So let's get into it. First up, flashcards. These are fantastic for boosting accuracy, especially in the early stages of learning math facts, that acquisition stage. Flashcards can be used one-on-one with a student or in pairs or small groups during class time. Here are the best ways to implement flashcards. Start by assessing the student. Figure out which facts they already know. If they can answer a fact within 2 seconds, that fact is considered known at this stage. Separate the known facts from the unknown facts. Begin with a manageable number of flashcards from the unknown facts pile. 8 flashcards may be ideal. For younger students or struggling students, you might want to start with 4 unknown flashcards. Use your judgment here. Begin by modeling the process and saying the facts. Go through each of the 8 cards. First, hold up the card and say, 6 times 7 is 42, and then ask the student to repeat it. Do that for each of the 8 cards. Now the challenge. Go through each of the 8 cards and ask the student to answer the math fact question. Hold up the card. What's 6 times 7? If they nail it, fantastic. If not, provide the answer and have them repeat it. 6 times 7 is 42. Go through the set of 8 cards at least 5 times per session. After 3 consecutive days, if the student can accurately respond, swap out the known facts with new ones and repeat. If they're still inaccurate, extend the practice with the same facts for a few days. Use your judgment here. Flashcards are simple to use and effective, and you can adjust the process depending on the student. You could say mix in known facts and unknown facts, especially for students who get frustrated. For example, you could present 7 knowns and 3 unknowns for that extra encouragement and for some practice of known facts. Or you could use a procedure called incremental rehearsal. Think of incremental rehearsal like this. Say you're practicing a new piano song and you're focusing on a new section that you don't know that well. So you practice the new section, and then you add in a familiar part, and you keep adding more familiar parts, all the while practicing that new part until it all flows seamlessly. It's kind of like that. For math facts, incremental rehearsal works by concentrating on one unknown fact at a time and interspersing it with facts the student already knows, gradually increasing the number of known facts in the practice set. It goes like this. Say the unknown fact is 6 times 7. Start by showing the flashcard and asking the student to repeat. 6 times 7 is 42. For the first set, hold up 6 times 7. Student says 6 times 7 is 42. Now hold up a math fact from the known pile. Say 3 times 5. The student says 15. Second set, hold up 6 times 7. Student says 6 times 7 is 42. Hold up 3 times 5. They say 15. Now hold up another known fact. Say 5 times 5, and the student says 25. Repeat this process, adding a known fact every time until your last set starts with one unknown, 6 times 7, and 9 known facts. Now in the next set, 6 times 7 enters as one of the known facts. I'll include a video on the resource page, which was provided by Dr. Matt Burns, who I also had on a previous episode. Next up is the cover copy compare method. This is great for building accuracy in that acquisition stage. It's perfect for individual use or class-wide. Plus, it's not limited to math facts. It's also effective for things like learning to spell and mastering other foundational skills. I kind of think of it like this. Say you're trying to sketch something from memory, like a picture of a dog. A good way to do that might be to examine the picture of the dog, cover it up, and try to sketch it, then compare your sketch with the original, fixing your sketch where necessary, and then repeating the process until you get it right. Cover, copy, compare is kind of like that, but for math facts. A cover, copy, compare worksheet has a math fact with the answer, like 6 times 8 equals 48, plus an empty space beside it. There are around 24 per page. I'll put an example on the resource page if you'd like to follow along. Here's how it works. The student looks at the problem. So start by having the student read the problem and its answer. 6 times 8 equals 48. This could be out loud or in their head, depending on the setting. Cover it. They cover up the problem with their hand or a piece of paper. Now they should try to answer from memory. They try to write down the problem and answer 6 times 8 equals 48 in that empty space. Then they uncover and compare. So they uncover the original to check their answer. If they're wrong, they cross it out and rewrite the correct one. This method offers repeated practice and feedback. Students can write, say, or think of the answer depending on your approach. Writing provides a permanent record and may be ideal for class-wide instruction, though it takes more time, especially if some students have handwriting deficits. Saying the answer aloud or thinking it can increase response rates. However, if a student fails to increase their fact accuracy or fluency over time, you then don't have tangible proof that they engaged in what's known as a learning trial. In other words, that they paired the problem, 6 times 8, with the answer, 48. So this can make it harder to measure improvement over time. Use your judgment to choose the best method for your setting. I'll link to some free worksheets on the resource page so you can try it out. Now, let's talk about taped problems. Taped problems can be used in both the acquisition stage and the fluency stage. This is a great method, perfect for use in a classroom or one-on-one, and it's fun because students try to beat the computer. There are 2 ways you can do this. You can use the audio files and corresponding worksheets that I've linked to on the resource page, or the teacher, parent, or tutor can act as the computer by providing the audio cue, which would be the problem, 6 times 7, and feedback, 42. But if you're recording scores, you will want to download the worksheets. Here's how it works. A computer reads the problem, say 7 times 8, and pauses for 2 seconds before revealing the answer, 56. Students try to beat the computer and write down their answer first. Then the student checks the answer. If the student gets it wrong or runs out of time, they write in the correct answer, recording their overall score at the end. Taped problems increase both accuracy and fluency. Plus, it's a fun challenge for students as they try to beat the computer. Now, before we move on to the next method, let's take a moment to discuss games and their role in building fluency with math facts. Tape practice can be considered a game because students are trying to beat the computer. Tape practice has been shown to enhance both accuracy and fluency. You could also create a game like Flashcard War, using the flashcard techniques I discussed earlier. In this game, give students 1 or 2 seconds to answer each question. If they respond correctly, they earn a point, and if not, you get the point. This game can also be integrated with class-wide peer tutoring, focusing on known versus unknown facts and incorporating appropriate set sizes like 8 new facts focused on at a time. Flashcards, when used as I described earlier, have been studied and are known to be effective. However, many other games may not be effective. There are a couple of reasons for this. First, any method you use for building automaticity with math facts should allow for targeted practice. This is especially important during the acquisition stage. This means we need to be able to systematically select which math facts to emphasize, and many games don't do that. Second, the approach should promote high rates of responding, ensuring that students are answering a lot of math facts during the session to maximize learning opportunities and reinforcement. Tape practice is specifically designed to achieve these goals, but if a game doesn't incorporate designated sets of math facts along with high rates of responding, it's unlikely to be very effective. Also, the appropriate time to use games is during the fluency stage, when students are already accurate, but you're trying to increase speed, not during the acquisition stage. The last technique I'm going to talk about is explicit timing. This is a powerful and important tool for building fluency. It's introduced at the fluency stage. Time practice is crucial for students who are accurate but slow. Incorporating time practice is essential so that students become automatic with math facts. Remember, we're aiming for 40 to 60 math facts correct per minute. Accuracy is an important first step, but it's not enough. Think about the difference between a student who takes twice as long as another student with their math facts, and think back to the ladder I talked about at the beginning. Say the first student can answer 25 math facts per minute, and the second student can answer 50 math facts per minute. The first student will struggle more with problems that rely on math fact recall. In topics like fraction addition, they'll need more time to calculate common denominators, limiting how many problems they can complete in a session. Meanwhile, the faster student gains more practice, now widening the gap on an important math skill, adding fractions. With slower recall, the first student misses out on critical practice and is at risk of falling behind, creating a snowball effect in their learning. Now, we can get that student to a point where they're as fast as the second student, but this is where time practice comes in. The key with explicit timing is introducing it at the right time. Ideally, you should introduce timing when students are mostly accurate with their math facts, which means they're getting them right most of the time, say 90% of the time, but they're still slow. Assess students. If they're at or around 20 digits correct per minute, this is a good time to introduce explicit timing. By digits correct per minute, we mean that if the student writes 7 times 6 equals 41, that counts as 1 digit correct. This is good for assessing to see if students are ready for explicit timing. Students will then track their progress in terms of problems correct per minute, meaning we want to make sure they get 7 times 6 equals 42 with the aim to reach 40 to 60 problems correct per minute. Here's how explicit timing works. Provide students with a full sheet of math facts. Each sheet I'll link to on the resource page contains 72 facts, and have them solve as many as they can in 1 minute. Instruct students to complete the problems in order, working across the rows. This prevents them from jumping to questions they can already answer quickly. We want to ensure they practice all math facts and not just the ones they already know well. Progress monitoring is crucial in this process. Students should record their scores, that's in problems correct per minute, on a personal graph each day and aim to improve upon their previous scores. This builds fluency and fosters a sense of accomplishment. Celebrate their hard work and remind them of how far they've come and how it will benefit them when they learn new math concepts. Again, consistent daily practice is important, and try to distribute time practice throughout the day, perhaps once in the morning and once in the afternoon. This approach has been shown to increase learning rates. Through a combination of time practice, performance feedback, positive reinforcement, and consistent daily effort, students will see measurable progress over time, giving them the confidence and skills they need to tackle harder math concepts which is ultimately our goal. I hope you find these strategies useful. Again, the techniques I discussed today have been shown to work with a wide range of students across age, skills, and settings. Remember, the key to success is frequent short practice sessions combined with plenty of encouragement, and daily practice has been shown to be the most effective approach. Aim to practice math facts every day, not just every other day or once a week, but consistently for at least 4 minutes each day. Building automaticity with math facts is an essential investment in a student's future. The time and effort you put in now will pay off, saving them from frustration and challenges down the road. Once again, a huge thank you to Dr. Brian Ponce for his invaluable contributions to this episode. Now, we need your help to reach people who could benefit from this information. So please do me a favor and share this episode with your networks. Until next time, keep practicing those math facts. As always, we've included a resource page that has links to articles and books mentioned in the episode. If you enjoy this podcast, please consider showing your support by leaving a 5-star review on Spotify or Apple Podcasts. Chalk and Talk is produced by me, Anna Stokke, transcript and resource page by Jasmine Boisclair, social media images by Nicole Melem Gutierrez. Subscribe on your favorite podcast app to get new episodes delivered as they become available. You can follow me on X for notifications or check out my website, annastokke.com, for more information. This podcast received funding through a University of Winnipeg Knowledge Mobilization and Community Impact Grant funded through the Anthony Swady Knowledge Impact Fund.